Hello there. So what you have in front of you on the screen right now are the notes that were sent to you through eBackpack last night that hopefully you downloaded into your classwork section of Notability. And if you haven't, you're going to want to do that now so that you can follow along with this video. So we are going to be moving into a little bit more of Chapter 3 today, and we're going to be going through distance word problems, and in your textbook it is Chapter 3.4. All of these word problems are going to be dealing with distance and rates and speeds and times and different modes of transportation, so sometimes you might hear them called as motion problems. So the first thing you'll notice after the title page are the let statements and the steps that we follow in order to solve these types of motion problems. So they are word problems, and we've been working on those quite a bit, and our goal for word problems is always to figure out what are we trying to solve for, and we always set up our basic unknowns in our let statements. So we're still going to do that. This is the beginning of what we call chart or table questions, because if we set up a table or a chart, it's actually going to make it easier for us when we go through the math, and we'll be able to figure out what it is we need to solve for, and we'll be able to solve it a lot easier. So when you set up your table, and you can set one up and copy and paste it throughout the whole notes or homeworks and things like that. So the first column is your person or thing, because sometimes we'll be talking about people moving, sometimes you'll be talking about a truck, a bus, a train, so that would be a thing. Then your next column would be your rate, how fast are they going, the time, how long it takes them, and then your distance. You're only having one column that's your unknown, so you're usually either finding the rate or the time. Okay, the distance column is your rate times your time. So whatever that is for each item, that goes in your distance. Your equation then is usually using your distance column, putting it together in some mathematical way, solving for x, making sure it makes sense through your check, and then writing your sentence answer. So if you're looking for a rate, for example, you would say that train A is traveling at 100 miles per hour. If you're looking for the time, you could say after you find x, train A took 3 hours to get to its destination. Then if you slide down to the next page, you'll see the different scenarios that tend to happen. So we could be talking about two things or people moving towards each other. We could be talking about them coming away from each other. The difference between them, so they're leaving at different times, okay, figuring out how far they are between each other, or catching up to each other. Okay, so towards each other would be they left in opposite places, coming to one destination. Away from each other, they started in one place and they're going away from each other. The distance between them, so one's here, and we're looking for that distance. And catching up to each other, they start, one leaves, and then one leaves a little bit later. How long will it take for them to get to one another? And we'll go over different strategies tomorrow as to what am I supposed to use for each one, what operation am I supposed to use for each one. This video is just kind of an introduction to some of the basics, and then we'll continue it when I'm back tomorrow, go through your questions, give you some other tidbits to help you, and work through some more scenarios. So we're going to try some basic ones through this video. Okay, so you have 3 basic ones that we're going to start off with. So let's start with this first one. A destroyer, which is a ship, traveling at 40 knots, and a battleship traveling at 30 knots left the same naval base at the same time and sailed in opposite directions. In how many hours were the ships 350 miles apart? So what we need is our let statement. Let x equal hours to be 350 miles apart. And then we need our chart, so we have our thing, which would be our destroyer, and our battleship. Our rate, so the destroyer is traveling at 40, The battleship's traveling at 30. Knots is just a way that ships use to figure out their speed. So it's just a unit of measurement. They left the naval base at the same time and sailed in opposite directions. So our time is what's unknown. So that becomes x. And then our distance is 40 times x and 30 times x. Okay, rate times time is your distance. How many hours were the ships 350 miles apart? So for this one, I'm actually going to use my distance column, add the two together, and set it equal to what miles they went. Add up the 40 and 30, divide by 70, and we would get, let me put this in a better color, x would equal 350 divided by 70, which would be 5. So our sentence would be, it would take 5 hours for the ships to be 350 miles apart. All right, so this is an addition problem because they are going in opposite directions. They left at the same time, and we're trying to figure out their distance, their time for a particular distance. Okay, so let's leave that up for a couple more seconds for you to copy what you need to. All right, and now we're going to try this next one. At 8 a.m., 2 cars started traveling from the same place. One's traveling north at 35 miles per hour, and the other's traveling south at 40 miles per hour. At what time were they 300 miles apart? So same deal, we need a let statement. Let x equal the time they were 300 miles apart. You need your charts. So thing, rate, time, and distance. So with this one, you have 2 cars. One's traveling north, one's traveling south. So you could just write north and south for your thing to indicate the difference, since they're both cars. Your rate. The north one's traveling at 35 miles per hour. The southbound car is traveling at 40 miles per hour. We're trying to find the time. I know it gives you 8 a.m. That we're going to use when we figure out our answer. So the time is actually our unknown at x. And again, distance is rate times time. So this one again is going in opposite directions. So I'm going to take my north plus my south and set it equal to the distance that they want apart. Add them up. Divide by 75. And we'll get x equals 4. Now 4 is how many hours, because you're dealing with a rate for miles per hour. So the distance, when you find the miles and you divide it, that's how many hours it took them. They want a particular time. So it took 4 hours. But we started at 8 a.m. So what is 4 hours after 8 a.m.? If you thought noon, you are correct. So 12 p.m. is when they will be 300 miles apart. Okay, again, this 4 is how many hours it took. We need the actual time, okay, just because of how it's stated. So just be careful of the wording there. All right, number 3. A northbound and southbound train left Toulouville Station at the same time. The southbound train was traveling 20 miles per hour faster than the northbound train. After an hour, they were not more than 100 miles apart. What's the maximum possible speed for the northbound train? So our x equals the speed. Okay, so we're actually looking for the rate this time instead of the time. It's a little bit different. Our things would be the north and south train. Your rate is what we don't know. Okay, that's what we're trying to find. So the southbound train was traveling 20 miles per hour faster than the north. So the northbound train has to be x because the southbound train is in a relationship with that. We're doing something to the northbound train to get the southbound's rate. So that's why we're going to get x plus 20. The time is after an hour. They were not more than 100 miles apart. So the time is 1. The distance is the rate times the time. So 1x for north and 1 times x plus 20 for the south. They were not more than 100 miles apart. So this is actually an inequality, less than or equal to. Distances get added. Because I'm multiplying by 1, I can just write x plus 20 is less than or equal to 100. We're going to add up our x's. So we'll get 2x plus 20 is less than or equal to 100. We'll subtract by 20, and we will get 2x is less than or equal to 80. We're going to divide by 2 and get x is less than or equal to 40. So the maximum speed is what we just solved for. So the max speed, or the maximum speed, of the northbound train is 40 miles per hour. Now I can use the 40 because I have that equal to. All right, the last thing I would like you to do for the remainder of class, you can go to your textbook, go to Chapter 3, Section 4. You're going to look for Practice Worksheet 1. And then in eBackpack, there is the assignment for what question numbers you need to do. Please look at that. You're not doing all of them. The questions that you should be working on should resemble the 3 that we just did together. I will be back at school briefly after school today. So if you need help or anything like that, try to come tomorrow morning. That would be the best. But if you have like a really quick question, I should be in my room right after school. So again, that's worksheet 3.4.1 from your iBook. Look at eBackpack for the assignment for what questions you need to answer. Again, they should resemble the 3 that we just did together. The video is posted in eBackpack for you if you need to rewatch it. And then tomorrow we will go back over all of this to answer any questions that you might have. All right, have a great day.